Welcome to the third workshop of the day, I think. I'm losing the numbers. Today, I'm going to try to do something pretty hard for a short workshop, that is to introduce you to a new AHP in the ANP library for Python and tell you a little bit about it. Actually, this is not the first Python library that has the ANP calculations. There are two more. The first one was developed by Bill Adams, that you were just with him, some of you at least. However, it has more of academic use because it has different types of calculations, while this one is more focused on giving you exactly the same results, exactly the same logic of super decision, but this time using something a little bit different, Python, and on top of that, giving the ability to those of us that do research to be able to edit and change the algorithms so you can make your own calculations and your own hybrid methods. So that's the idea, that it's open there for all of us to try, edit, change stuff in order to compare with other methods and get easily results instead of trying to kind of use Excel or MATLAB alternatively. But let's get going. Today, I'm going to go through just the initial idea. There are quite a few things related to the Python, and I hope that soon we will be also able to give a full set of tutorials for all the different aspects as video tutorials. So, initial idea, do something for educators to teach AHP and ANP. I know we have super decision, but it's getting a little bit harder to handle in some situations, especially with newer operating systems. And we also wanted to try something new. We wanted to give something to the researchers to be able to set up not only their models, but their own calculations and combine them with other existing libraries and optimization setups. And also, we wanted the researchers to be able to tinker with the algos and evaluate all the effects of those results. And all that while doing both group and standalone decision making. So let's get in. How does it work? You do need to install a Python environment. And the first time, yes, admit it might take a long time, but you do it once and you have it forever or almost forever. So it's worth the pain of the first time. Also, it gives an ability in the tool, especially to our students, that is really invaluable. It's right there, state of the art, cutting edge. Everybody wants to learn Python. Add to that optimization and decision making like AHP and ANP, and you have a perfect setup. You will be able to create Python files or Jupyter notebooks. So the idea is that when I do stuff for myself, because I want to create a model and set it up, I usually create my own Python file because I want to put everything nice, neatly in there and quickly get results. While when I'm teaching, I usually use a Jupyter notebook. The difference is that you put, and you'll see me doing both of them today, you put piece by piece the code and the student can see immediately the results of that piece of code. And again, so step by step as you are building the model, you also see the structure inside the system. Now, for the model, we should be able, by the end of this meeting, set up a model, export questionnaires or import judgments from Excel. And also, this library has the ability to handle SurveyMonkey, Google Surveys, and Qualtrics. Now, because from my university, I have access to Qualtrics, that's the one that we are going to do today. As we all know, especially in ANP, we generate big questionnaires. So the idea is that I need a place that I can have access to a big questionnaire and be able to do it. That's why I'm using Qualtrics. Google Survey is a really good alternative. It's just that in order to set up, for example, the Big Burger model that we all know, you will need the paid version. It's not very expensive, probably a few dollars a month. But anyway, I didn't want to put you through that setup today. Having finished the exporting to whatever tool we decided, Excel or a survey tool, we collect the information, and either it is one set or multiple, so we are talking also about group, we bring them back to Python to do the final calculations, sensitivity analysis, inconsistency reports, all that stuff, and anything else that you will add to it. Let me tell you a little bit about the implementation. The structure that we are actually going to follow. We'll create a model, we'll import the libraries that we need to import, we'll create a model entity, very similar to the create new file when you were in super decisions. Then we define nodes, and by defining a node, we mean that we are going to give a variable name to save the node, a label, that's the real name of the node, and also we'll have to decide the display order, and it is, remember that, an overall display order. If you put different display order numbers to nodes that belong to the same group, later on, you will need to change the order, otherwise both your pairwise comparison matrices and your super matrix will reflect the order that you said. And if it's not correct, it could be kind of messy. But there is no reason to worry because you can change the display order at any point of time. There is a command that allows you to change the order. So if you see that something is going wrong, just go ahead and change it again. Same thing for the clusters. At this point, we haven't made yet a connection with anything. We assign nodes to clusters. It's very object-oriented, the whole approach. We assign clusters to the model, clusters that already contain the nodes. And then only inside the model, we can start creating connections. And the reason is because you can reuse the clusters and the nodes that you created in different models. But the relationships are something particular for a specific model. And if you want it exactly the same, just copy the model object. That's also possible. Then we create questionnaires. Right now, the library provides 3 different types of questionnaires. The full, the painful full, as I call it, especially in ANP models. A short one that is only the first line of the pairwise comparison and the first line and above the diagonal. But given that all the functions are open, you can create your own cover sets and set it up as would work better for the situation that you're solving. At that point, you will be able to export to Excel, collect the judgments, meaning someone has to type in either in Excel or in the survey tool that you are using the judgment. Import the finished, the completed pairwise comparison matrices, and then Python call the commands to calculate limit matrix, weighted limit matrix, super matrix, inconsistency report, if you want sensitivity analysis. Right now, we have only the old AHP sensitivity analysis, but I believe that within the next month, we will have also the sensitivity analysis that Bill was talking about, the raw sensitivity for the ANP models. Okay, that's the general idea. Let's go. This is a model. When you start setting up a model, you're really creating an empty box, nothing, zero. It's just a container. A little bit of brainstorming and a lot of disagreement later. You will have some nodes, few nodes here and there. You have here different groups of nodes from me, nodes 1 to 9. And you will have some clusters. No connection there. That's the initial point. I know my nodes. I know the decision factors that I want to consider. And I'm having an idea of what kind of organization, what kind of clusters I need to use. And from there, the next step, that is easy, but not so easy when you see the conceptual side of it, we will need to assign the nodes to clusters. And of course, add the clusters to the contained nodes. So we are taking one by one the objects and putting them inside that big container that was the model. Little by little, everything that we create will end up being saved inside this hot pink box that I have, the model object entity in Python. So that's the idea. The model will contain at the end all the information and all the calculations that we are doing, including the connections. We don't have a way to really separate AHP from ANP. I mean, you don't need to. We do in the calculation side of it, and you will see that there is a calculation that says check if AHP the model. But while someone is developing a model, they don't need to define at any point whether they want an AHP calculation or an ANP calculation. And my most valuable players, the functions that we are going to see in just a second in Python. Let's see how they look like before we go and add the complexity of that. Yes, I'm bringing you slowly in a development environment, as you see, because we will have to actually put commands in there. But for now, we are still on our slide. You create a model at the beginning. Do you really need to do it at the beginning? No. However, that's how we are used. We start thinking about a model, we name it, and we know that it's there waiting for us to do stuff. We start creating the nodes, as many as we want. See, at the left of the equal sign is the name of the variable that we are going to use. That's something that only us will know. Then we have the label. And the 0 in this case, because it was my first node, is the display order of that specific node. Same exact thing with a cluster. Now, if you're wondering, the command is the name of the library that I'm using. CDF str would be CDF structure, that's why. But this is a nickname that I have given to the library. You can call it, I don't know, perfect library or whatever name you want on the front, and then dot, that's the important part. Node is the command to create a node. Dot cluster is the command to create a cluster. And when you want to add a node to a cluster, you say the variable name of the cluster, add node to cluster, or remove when you want to remove node from cluster, and you refer to the variable. That's one of the few places that we refer to the nodes and clusters by their variable name. And the reason is simple. At the beginning, while you're still brainstorming, you might use the same name for more than one node. And we don't want everything to come crashing down and not be able. So we refer to the variable names that anyway the environment will not allow you to create two with the same name. After you add your nodes to the clusters and you remove them and you add them again until you end up to the model that you want, you will be able to add all the classes one by one to your model, that is this array over here that we have. And start setting up connections. You can add connections in 3 different ways. Over here, you see just 2 of them because they are my favorite ones. Add node connection from a node to a node. Add a node connection from a node to all the nodes of a cluster. And add node connections from all the nodes of a cluster to all the nodes of another cluster, like saying all the alternatives connected to all the criteria of this cluster. Or from node to all nodes, all the goal needs to be connected to all the criteria. So it's just a command in those cases. Notice that I have quotes. That means that I'm applying this to the label name, to the actual node name, not to the variable anymore. There are commands also for the variable names, but it appears that most people prefer the labels. So that's what we are seeing today. At any point of time, while you are doing all these commands, you will see that we receive some interactive messages from the system. However, if you want to review what you have done, you can always use the show all node connections and show all cluster connections setup. Now, that was nice. And of course, you generate the questionnaires, full first line above diagonal and first line questionnaire. And let's go to a very simple lunch exam, because I think that it would be pretty helpful for us to see how we would set up something like that in the Python environment. What is the decision goal? Find out where to get lunch today. My options, all three around here: Primanti Bros, Chiada, and Panera. These are three options. These are the alternatives that I want to consider. And I'm going to use as my decision factors quality, price, menu items, and speed. The difference really, it's the same. They are within the same block around my office. That's why you don't see me putting in the distance. And I know that it's a super simple model for you. However, Python is new. Let me go for the simple one before we see something more complex. So this is what I'm going to try to set up on Python. Now give me just a second, because I have to bring you to the dark world of Visual Studio Code. And since this is the first model that we are doing together, and maybe it's also one of the first for some of you in Python, I'll take you to the more entertaining setup, that is the Jupyter Notebook. A Jupyter Notebook is a place where you put lines of code and you will see results underneath. And again, a little bit of code, a little bit of results, very interactive and very good when you want to display things happening. Over here, the first lines that you see are all my imports that I need to do. Later on, we will replace that with a closed package. But while it's still in development through the community, the AHP community, it will be open, so you will be able to see imports of actual libraries. Over here are the three important files for me. One is called AHP InputsLib, StructLib, and CalcLib. How to handle inputs, how to structure a model, how to do calculations. And because our purpose is for you to be able to edit and change this stuff, I'm going to also give you a very quick tour over there so you know what we are going to be using. I'll start from the structuring because it's probably more straightforward. It's the place that we define the model that I talked about, the clusters, and the nodes. These are the three big objects for our AHP ANP library. You have clusters, and each of these clusters, you can see with me in the outline that you can set up calculate the node connections, the cluster connections of a model, find out all the pairwise comparison matrices, the vectors, and a lot of other, including the questionnaires. So the model is what holds all the information, but it uses as a building unit the cluster. And the cluster, as you see, has the name, order, and ID, but it also has the nodes and also the other clusters that is connected to. And very similar, we have the node with the same information along with which cluster is its parent cluster. So the point here is that you really can read through the calculations and make sure that you change when you want to change what you want to change and make it work exactly as you need it to be. If you're just, that's not exactly just, if you're teaching the method to other people, you can still stay from the other side and don't let them go to the coding side and just show them how to set up. So now that I have my libraries, I don't know if you noticed, I click that small arrow in order to make sure that my libraries have been loaded. Whenever I run a command in a Jupyter environment, you will see a small number in the left corner or a clock. If it's a clock, it's still processing. If it's a number, it means that that block of code has been completed and I can go on. Even if you didn't have something to show up, it's done, it's ready. Now, next thing is for our lunch model. to add the model creation setup. So let's go and create, I'll call it launch model. And I'm going to call my library, the CDF str structuring, in order to create a model. As you see, I don't have a very good memory and I don't need to remember. It brings up the autocomplete, so I know the command that I will need to use. I execute. So I just created the model. Really? Did I? Well, if you were looking at the terminal at the bottom or the right hand, there is an option over here that says what's happening in the model. And yes, I just created a launch model set up over there. Model in place. Let's start adding nodes to our model. But what does a model really mean? I'm going to show you an empty model by printing it out. Here's how my empty model looks like. It has the structure to contain nodes, clusters, node connection, and cluster connection, but nothing is there yet. Next step, let's add some nodes. I want my goal node, which will be same library. And now I'm talking about nodes. I need the node command. And as I open the parentheses, you will see that it's telling me what to use inside the parentheses in order to create. I'm going to call it goal node and order it as 0. And since I'm here, I would like to create some more nodes. I think that I said that I would like a quality node for my model. Now, I don't know if you know, but I really don't like typing a lot. So you will see me using my quality node, and I'm good. My price node. Do I need to call them like that? No, it's just that I'm used to put a little bit of the actual name in so I can find them easily and keep an eye on them. Do I need not to put spaces? No, it's because I have used super decisions on many years that I don't put spaces by default immediately. And I think that I wanted also a menu node. Notice that I haven't changed yet the orders. I do remember that I have to do it. And my fourth node would be speed. And I have my nodes in place, and I'm going to update my order just so we know what's happening. And here we are. And I'll also, I'm going to execute my code so we can see that everything is working correctly.
Quality is the most important node. Am I right, Elena?
That would be in my perception, but that's really up to the person that is working on it. So yeah, for me, yes, I think that quality is the first one, so I'm putting it on top. It's also the one that I feel that I can easily enter judgments for. And because I'm planning, and I know it, to use the first line and above the diagonal mostly, we want it to be there. So I have everything compared to quality. Mm-hmm. If you see on the right-hand side, you see that I have created already my nodes. I could print them if I wanted. And I could see by printing them what's the situation there. And you print as you saw me printing before, just by using the word print and inside the parentheses, your setup. And you can do it for as many as you want. I just did this one node to see how it would look like. Now that I have my nodes, I think that I'm ready to add also my alternative nodes. So I'll have 3 alternatives. They are also nodes, so I'm going to follow the same setup. And I think that I had 3 mantis. That would be my number 5. Manera piada, no particular order. And I have my alternatives as well. You see them being generated on the other side. Clusters. I will be using my 3 usual clusters. Let's get 1 for criteria, 1 for alternatives, and 1 for our goal node. And I'm going to also print all of them this time. Clusters in place. Next step, we need to add the nodes to each cluster. First, I'm going to use the simple command. Yes, the one that I don't like that much. So I'm going to do a cluster 0, add node to cluster, and the name of the variable that I was using up here, goal node. While for cluster 1, I'll do exactly the same thing for all the clusters. So you will see me copying a lot. And we will have for cluster 1, the criteria that we want. 1, 2, 3, 4. And then 3 alternatives. I haven't changed yet the names of the variables. I'll come and do it in a second. Here, I can copy and paste, but I'm also able to see them next to me. So it's pretty easy to say that I want the menu node in, the quality node to it. Notice that it doesn't matter the order that I'm putting them in, because I will be taking everything based on the display order that I set up. Menu, quality, price, and speed. And my alternatives, 1. Oops. I would appreciate if I typed it correctly. And we can execute this part of the command too. And just because I'm sure that you're wondering, even if I do a print here, you will not see anything because it's not in the ID of the cluster. There is, however, another way to see the contents of the clusters, which we are going to see in a second. That's why I showed you that that printing would not work, but this printing, print with nodes, will give you what are the contents of your cluster. Nodes in the game, clusters in the game. We associated the nodes with the clusters. Now it's time to tell to our model that contains 3 clusters. We called it lunch model. And I'm going to say lunch model, add cluster to model for my 3 clusters. And now you remember that I had printed out the model and we saw it really empty. Let's see how it looks now. Here it is. I have my nodes with all their information. I have clusters, no connections yet. That's the next thing that I need to do. I'm going to set up my connections. And the first time I'm going to use the add nodes from node to all nodes of cluster because I'm going to go from my goal node to the criteria clusters. Now I will need my goal node. It is. And my cluster, which would be criteria. From the goal node to all the nodes that are contained in the cluster named to criteria. And done. And now I want all the criteria to all the alternatives as a full setup. So I'm going to use add connection from all nodes to all nodes of clusters. So let's see. Two criteria, 3 alternatives. Looks good. And if I print one more time my model, I should be able to see everything that I need in there. Full connection setup. And I could also make sure that nothing got messed up by saying, show me either all the cluster connections or all the node connections from a specific one, and all that. But we have a very fast workshop today, so let's stick to the show all connections for the clusters. That is the most important one. Next step, we can generate any type of questionnaire we want. I'm going to generate a full questionnaire and I'm going to also print it out so you can see how it looks like. It's not to be used, it's only to be displayed and used later from the code itself. I'm going to display it to you because we need to set it up for our purposes over here. And let's see. That's what we are going to use as a base for the questionnaires, both in Qualtrics and Excel. That's why I'm printing it out. This is a full questionnaire. You can also set up any of the other setups. I'm going to show you, for example, the first line and above the diagonal. Now, the first line on above of the diagonal and also the first line only makes sense when you are exporting towards a survey tool. When you're exporting to Excel, because you will be exporting the Excel spreadsheet itself, doesn't really make sense to go for a shortcut because the table is the same. It doesn't change because I'm saying that I'm going to get only specific pairwise comparisons. And we wanted also the shortcut. So generate first line. And you see the word, that's the word that is being used. In my case, I'm using the first, the dominant, which one is more dominant, instead of saying which one is more important or preferred or likely. And here we have a very shorter questionnaire. Now, having an idea of what we are trying to do, we should be ready to export to our main tool, that is export to Excel. We could also export to any of the questionnaires. If you click the dot, you can see all the different types of export that you can do. You see the export and import to Excel, but you can also see that you can generate export for Google, Qualtrics, and somewhere around there will be also the SurveyMonkey. Here we are. That means that I'm going to generate a lunch empty Excel. That's the name that I'm giving to the file. You see my file over here getting generated, and you can see a preview inside my environment, but I know that it doesn't look very readable from here. So give me a second and I'll take you with me and see the file from within Excel. Here we are. This is the Excel that was automatically generated from our model. You can enter the values that you need to enter. And as soon as you have filled it in, you can go back and import it in the system. See, it's each cluster, then all the pairwise comparison matrices that correspond to that, and you continue with the next cluster and goes on. This is a very simple model, so it doesn't show the whole complexity. It can get to be a pretty long set of tables over here. And now going back to our model over here, let's assume that we were really good and diligent and we put all the judgments in. And that means that we can import back the information that we just exported. So now we will be doing an import from Excel, the name of the file. Let's see, do we have a filled in file in this set? We are going to go here, import from Excel. We'll say where the file is. Let's call this lunch pool XLS. 0 is the tab that I'm using from my, and of course my model is lunch model. And that's how I'm going to import all the information that I want for my model. And let me bring in some information for this one. And we'll have now, as you see, I imported the empty one, so we don't spend time filling it in, but immediately it will give me, obviously, just with once, the whole set that I read. I'm taking you right now to the car example model where we have the field in setup, and we all know the AHP car example model, so that's easy to see. And let me show you how it would look, the part of the calculations. So first of all, we have the ability to calculate the supermatrix. The moment that you import from Excel, you are really calculating all the pairwise comparison matrices. And from there, you will have the unweighted supermatrix of the model. You don't need to specify anything. And the limiting priorities of the model. And because it's a little bit easier to see the results, every time that you do a calculation, you can also export that calculation. It will generate it immediately in an Excel spreadsheet. So you can see the supermatrix, the limiting priorities that are the results, and the limiting priorities by cluster if you prefer to see them. So local and global priorities along with the supermatrix. And at the end, you can also do your sensitivity, your AHP sensitivity analysis for this model because it is an AHP model. And allow me here to run it. So we can see the sensitivity analysis being generated. Although I'm not sure that you can actually see it. Give me a second to grab the window for you. Here we are. This is the generated sensitivity analysis for the alternatives with respect to the first of the criteria.
Can you interpret it for us? I think this was AHP model, so we can interpret it. Yeah.
Yes, it's the AHP model.
Yeah. Sorry.
Yeah.
I must be sleeping.
What do you mean?
No.
Okay, so this is the end really of the setup where we have the sensitivity analysis. And I think that was almost the full quick tour. You saw that behind there were the rest of the sensitivity analysis. I have only just one more thing to show you, given that my browser would like to collaborate with me. Here you are. And we have, yes, this would be the view if you set it up as a survey monkey setup. And I think we have 5 whole minutes, but we went through all the basic points. I know that it's really painful the first time that you see something completely new. And I'm scared to ask you, Birsen, what you want to ask.
I think you don't expect us to write all these codes. So this is only if you want to teach.
No, actually, I do. Birsen, this is meant for people that want to use Python in order to set it up. It's not a graphical application. There are other applications that we have that are graphical interfaces. They are not one replacement of the other, really. This is because a lot of engineering and business schools nowadays teach statistics, data analysis, analytics, and all that in Python, so they can have also the decision-making component on top of all that in the same environment. So yes, I would expect someone that uses the Python library to use the coding. We will have a web interface for people that are not going to fill, but they are two different things, two different sets of applications. Don't see them as the same thing.
Mhm.
This is not a super decision replacement. This is a different approach.
So for big scale problems, we will do this coding.
If someone doesn't want to use super decision, they can do that. It
Yeah.
depends on what.
I would rather use super decisions.
It's a matter of choice, I guess. Yes, of course.
Mhm.
Enrique, did you want to say something? We can't hear you. Sorry, you're still muted.
Yes, thank you. This is very interesting. Now, the workshop has been about AHP, but do you have the libraries also for ANP?
It's HP ANP ratings and hopefully soon BOCR as well. That is really combining them, so it's not. But yes.
And does it generate the questionnaires for ANP too? Because some of the questions are a bit tricky and a bit different.
Actually, the workshop was just for HP because it's kind of the introduction to this kind. But yes, the same exactly commands would be used in order to set up the ANP model. There is no difference from that perspective.
Excellent, excellent. Congratulations. Thank you.
Thank you. I think that we will be needed to be closing in a couple of minutes in order to start the next one. But I think that we can take one more question if we have. All right, then. Thank you. And I'll see you in a few minutes in the next.
Absolutely.
Okay. Thank you.
Thank you.